Hello, everyone. My name is Anay Ravindra, and I'm the Vice President of the Youth Science Organization. We will start our STEM topic videos with evolution and natural selection. So, what even is evolution? Evolution is the notion of change. Evolution is not a cow wanting to get an apple at the top of a tree, so it magically gains a long neck. It is natural selection. Environmental factors will choose the variation necessary for natural selection and the production of offspring generally. The term natural selection became popular by Charles Darwin when he wrote about it in his book on the origin of species. A prime example of variation in natural selection is the peppered moth. Basically, what happened is that in the pre industrial revolution of England, there were generally three variations of moths, depending on the amount of peppered or white colors on their wings. Then, when the industrial revolution hit and the production of smoke through coal powered steam engines increased, the variation of moths chosen would be the fully peppered variant. When tree trunks became blackened from the lighter tone they used to be prior to the industrialization, the variety neglected was the one that could not blend in with its subcovered environment. If the environment became blacker due to the industrialization, predators such as birds could easily identify the white moths, rather than the peppered ones. It is not like the peppered moths would never have been caught. Every variant would be caught, eventually, but the white moths would have been frequently preyed upon. A couple things to understand about natural selection is that changes to an environment can alter the organism's fitness to reproduce. What we mean by fitness in a biological sense is that fitness is the ability to pass on one's genes in a given environment. The more offspring an organism has, the fitter it can be. A misconception that arises when studying the topic of natural selection is that individuals evolve. Individuals cannot evolve, populations do. Individual organisms have set genes. They cannot swap them out for one or more favorable ones. Populations, however, can change their composition over time. If a gene gives an organism an advantage, the likelihood that the genes will pass on to the rest of the population will increase exponentially. But if genes cannot be swapped out at will, how do populations obtain these genetic variations? Random mutation is responsible for this. Think of it like a dice. Three sources of variation are positive, negative, and neutral. Positive mutations make it so that the organism is fit and lives long enough to reproduce. Negative mutations decrease the fitness of an organism, and neutral mutations have no impact on the fitness of an individual. Our second misconception is that variation has a goal. Variation is pretty random in actuality. Jean Baptiste Lamarck proposed the idea that organisms acquire useful traits, then pass those on to their offspring. This has been debunked because he stated that giraffes, to get their food at the top of a tree, would extend their necks for years and years, then manage to have an offspring that would have longer necks as well. Variation has its pros and cons. Some pros include helping an organism develop to survive in adverse conditions and deflect diseases. Variation creates diversity, which is key to a successful ecosystem. Some disadvantages include getting undesired effects like genetic disorders and diseases. Now we can switch our focus to different types of natural selection. They are directional, stabilizing, and diversifying selections. In directional selection, one extreme characteristic is favored upon over the average. We can connect this back to the peppered moth scenario in England, as the peppered moths were favored rather than the moths that still had a white pigment. In stabilizing selection, the average characteristic rather than the extreme is favored upon. For example, some male peacocks have bright, luscious feathers that female peacocks find attractive because it looks like as if they are fit. The male peacocks that do not have many feathers appear as if they are weak in the eyes of the female peacocks. They tend to survive longer in actuality compared to the fit-looking peacocks because they easily attract predators, making it harder to reproduce, while the less fit-looking peacocks can evade predators easily. In diversifying selection, both extremes are favored. This type of selection is pretty rare compared to directional and stabilizing. A prime example of this is the rock pocket mice. The southwest of the United States is generally covered in light-colored sand, with patches of dark rock from a volcano eruption that occurred nearly 500 years ago, called the El Malpais lava flow. The lightly colored mice hide from predators in the light-colored sand region, and the darker colored mice reside in the patch of dark rocks to preserve themselves from predators. Before the eruption, the dark-colored mice were at a disadvantage because they could not effectively hide in the lightly colored sand region due to their color, but because of the eruption, both extremes of color were favored. The intermediate mice, or the mice with gray colors, could not survive in either region, depicting that only extremes are favored in diversifying selection. That's it for now. Thank you guys for watching this informative video on natural selection.